Okay, so let's see. How do we get this? Okay. So to get this, we observe that this is a key observation. This key observation allows us to simplify the problem. The key observation is that this 1 plus x squared plus ... You can represent it by 1 over 1 minus x. Strange, but that's true. Let's see why this is true. So let's multiply 1 minus x to this side. Okay? Okay? So what is the constant term of this thing? If we multiply this together, it must be 1 times 1, right? So this is going to be the constant term. And what is the x term? How do we get x term? So x term, it is minus x times 1 plus x times 1, right? Is that okay? Minus x times 1 times x plus x times 1, it is going to be 0x. Is that okay? How many x squared do we have? So it must be minus x times x, and then this x squared times 1, right? So it cancels out. So you have 0x squared, 0x cubed, and so on and so forth. So this is equal to 1. Is that okay? Does that make sense? Okay? Or if you don't like, you have another representation. So this is 1 plus x squared plus ... Okay? So let's say this is the function x that we are looking at. Let's multiply x to this function of x. Then we get what? We get x plus x squared plus x cubed plus ... Is that okay? This one minus this one, you get 1, is equal to 1 minus x times function of x. Is that okay? So function of x is equal to 1 over 1 minus x. That's the same. That's the same as I'm doing this, but this is perhaps easier to recognize. All the terms here, you get cancelled. You get just one left. Okay? Okay, good. So this is the key observation that we have. Okay, let me wipe this off. So this is just for double checking we are correct. So this is equal to what? 1 minus x to the power minus n. Sorry, to the power 1 minus to the power minus 1. Is that okay? And then this is like this. So the generating function here will be rewritten as 1 minus x to the power minus n. Okay? And suddenly we can apply the binomial theorem. Okay? So how many ways are there? So let me wipe this off again. So we can have some space for our problem. So our problem now is we want to find out the coefficient of x to the power r in 1 minus x to the power minus n. Is that okay? So this is going to be what? This is going to be minus n minus 1 minus n minus 2 so altogether there are going to be r terms times minus 1 to the power r. Is that okay? Okay. This comes from this binomial theorem, the term. And why do we have minus 1? This is minus x, not plus x. So we have minus 1 to the power r there. If you are okay with what I'm talking about so far, could you please raise your hand? Okay, good. Okay, this minus 1 to the power r is nice because there are r terms here. Each one of them is negative. So this is going to be equal to what? It's going to be n times n plus 1 times n plus 2. The last term, n plus r minus 1 divided by r factorial. Is that okay? And then this is equal to what? This is equal to this term to the power r falling divided by r factorial. So this is exactly equal to n plus r minus 1 choose r. Is that okay? This is what we know before. Because the number of ways for this problem is to consider there are r balls, exactly r balls, and n minus 1 bars. So altogether, there are r plus n minus 1 things to permute, to arrange. And then we want to select which positions are the balls. So it is going to be n plus r minus 1, choose r. And that's it. Is that okay? So this agrees with what we understand before. Let's have another example, okay? Let's have another example. So, okay. Okay. So this is another problem. So suppose that we have 4 persons. And then each rolling a die once. Okay. And then we want to ask how many ways can the total score be 17? Okay, so for this problem, suppose that you have A, B, C, D, right? There are 4 persons. Let's say 5, 5, 3, 4. So we consider this as the same as 3, 5, 4, 5. Is that okay? So we want to ask about the combinations only, the number of ways. So 1, 3, 1, 4, 2, 5 is a combination. Okay, so it doesn't matter about the ordering. Okay, ordering does not matter. So how many ways are there to have a total equal to 17? So we can try to solve this using the generating function method. Is that okay? Let's do this. Okay, the first person. Let me see. No. Let me see. Oh, okay. Yeah, correct. So how do we solve this problem? Okay. So all we concern is how many kinds of objects that we can have. We can have 1 as the object. We can have 2 as the object. We can have 3 as the object, 4 as the object, 5 as the object, and 6 as the object, right? Right? Did I make... Let me see. Let me see if I'm making any mistakes. So there's 4 persons. Oh, sorry. It should be this one. This and this one are different. Okay. Let me change the problem a little bit. Okay. So 5, 5, 3, 4 is different than 3, 5, 4, 5. Okay. So this is the problem. So if this is the case, then we should look at what? We should look at how can A be selecting? How can B be selecting? How can C be selecting? And how can D be selecting? Okay? So for A, so there are 4 persons. For A, how many ways can A be selecting 0 point? So you can have 1, 2, 3, 4, 5, 6, right? As the point. So how many ways can A be selecting 0? No. So that is 0. How many ways can A be selecting 1 point? 1 way, right? 1 way. When A throws 1. Okay. How many ways can A be selecting 2 points? Also 1 way. Excellent. So it is like something like this. Right? Plus 0, x7, 0 in the end, right? So this is what happens to A. What A can do is A may be selecting 1, A may be selecting 2, A may be selecting 3, up to A may be selecting 6. And that's it. Okay, so this is the generating function for A. So we ask A to select some point. Okay, so A selected. And then B is going to select the points using the same generating function. C the same, D the same. So this is the generating function. So this is what? So this is going to be the generating function of selecting the total score. Is that okay? And then to solve our problem, we want to find out how many ways can the total score be 17. So we want to find out what? So here, the answer of this one is the coefficient of x to the power 17 in this thing. Is that okay? Okay. So once we have this generating function, so the answer that we want will be equal to the coefficient of x to the power 17 in the above generating function. Okay? Is that okay? Okay, let's find it out. Let's find it out. So what is it? So this time, let's rewrite the generating function a little bit so that we can use it more easily. So we rewrite the generating function as equal to, so x plus x squared plus x cubed up to x to the power 6. It is actually equal to x times 1 plus x squared plus x cubed plus x4 plus x5. Right? So this is the generating function that we are looking at to the power 4. Okay? Is that okay? And then this is equal to x to the power 4, because we have an x here, x to the power 4 here, times this part. If you still recall, this part we can write it as 1 minus x to the power 6 divided by 1 minus x. Is that okay? So we have this one to the power 4. Okay? So if you look at this, we will have the answer that we want is equal to the coefficient of x to the power 13 in 1 minus x to the power 6 divided by 1 minus x, this term, to the power 4. Is that okay? If you're okay with this so far, could you please raise your hand? And some get lost, right? So let's see. Originally, we want to find out the coefficient of x to the power 17 in the whole thing. But we notice that this thing is equal to x to the power 4 times this one. So you want to get x to the power 17 coefficient in this whole thing. It is like you want to get x to the power 13 in this part only. Is that okay? So this is what we want. Okay? Okay, so let's focus on this one. So what is it? So this one is, let's write it again. This is actually equal to 1 minus x to the power 6. Sorry. 1 minus x to the power 6 to the power 4 times 1 minus x to the power minus 4. Is that okay? Is that okay? So this is equal to, the first part, 1 minus x to the power 6, it is equal to summation of 4 choose I, x to the power 6I. Is that okay? Is that okay? So this is the first part, times minus 1 to the power, okay, so I forget this minus 1 to the power 4. So, no, minus 1 to the power I, yeah. Okay? Yeah, I always forget this minus 1. So this is the first part. And the second part is, you want a summation of what? Summation of, this time, we use the new notation, minus 4 to the power I x to the power I minus 1 to the power I. Okay? So this is the second part. Okay? And we are, is that okay? Is that okay? Good. And then, from this whole bunch of things, we want to get what? We want to get a coefficient of x to the power 13. So how can we get 13? Okay. So for the answer will be equal to what? So we want to get x to the power 13. So x to the power what kind of x can we get? We can get x to the power 0 here by choosing I to be 0. We can get x to the power 6 here by choosing I is equal to 1, and we can get x to the power 12 here, right? So when we get x to the power 0 here, then this part must provide x to the power 13, so that they multiply together, you get x to the power 13. Is that okay? So we have a case where this, you have 0. So it is 4, 0 times minus 1 to the power 0. Is that okay? And then for this case, this is the first case of the left-hand side. Then you want to multiply this with minus 4, choose 13. And then minus 1, choose 13. Is that okay? Does that make sense? And then this is the first case. The second case, we have a second case. The second case is when we set I is equal to 1 here. So you have 4, choose 1, and then minus 1, choose 1. Is that okay? And then this gives us x to the power 6 on the left-hand side. So we want to get x to the power 7 on the right-hand side. To get x to the power 7 on the right-hand side, it is going to be minus 4, choose 7, times minus 1 to the power 7. Is that okay? And then that's not the end. We also have another term that we have. So here, we may be choosing I is equal to 2. So you get 4 choose 2 times minus 1 to the power 2. And then 4 choose 2, then you get x to the power 12 on this part. And then we need x to the power 1 on this part. Is that okay? To get x to the power 1 on this part, you set it to 1. So it is minus 4 choose 1 times minus 1 choose to the power 1. Is that okay? Is that okay? Okay. So this is just easy evaluation. So 4 choose 0, we know that it is equal to 1. Right? Let me see. E? Yes, that's right. This is equal to 1. Minus 1 to the power 0, 1. This is minus 1, whatever. And then how do we get this? This is going to be minus 4 times minus 5 times minus 6. There are 13 terms divided by 13 factorial. Is that okay? So you can get the term for this one. You can get this. And this one 4 choose 1, you know. Minus 1 choose 1 to the power 1, you know. Minus 4 choose 7, you also know. Everything, you know. So this is going to be, okay, so actually, this is minus 4 choose 30. This you can cancel it. If you look at it, it's going to be minus 4, minus 5, minus 6, multiply up to 13 terms altogether. Each of these terms is minus. And then there are exactly the same number of minus sign here. Okay? So it is going to be, this term, this whole term, turns out to be equal to, this whole term turns out to be equal to 4 times 5 times 6 times ... divided by 13 factorial, and there are 13 terms here. Is that okay? Including this minus 1 to the power 13. So all the minus becomes positive. And then what is it? So this is a 4, and the last term is going to be 16. Is that okay? 16. So this is going to be 16 choose 13. It turns out that this whole thing is 16 choose 13. And then similarly, this whole thing, it is going to be 10 choose 7. Positive. And then finally, this whole thing, it is going to be 4 choose 1. Is that okay? So you can calculate this fairly easily. Okay? So this is another example of this generating function. Now, we don't have much time left, but I want you to do this at home for practice. So next time, we can check the result. Okay, so this is a challenging problem. So this is about the application of this binomial theorem. So this time we look at 1 minus 4x. And for the first time, we have not an integer here. This time, minus 1 over 2. Is that okay? Is that okay? Yeah, minus 1 over 2. So this is like what? This is what 1 over the square root of 1 minus 4x. Is that okay? So this is like this. And then we want to find out what is the coefficient of x to the power r. And then we want to show that the coefficient of x to the power r is going to be very beautiful. It is going to be equal to 2r choose r. Okay, so this is a practice at home. So let's continue the discussion next Tuesday. And then we will see. So today we have finished only part 1 and part 2. So next week, let's try to solve the related problems. So this is the first one. So if you are familiar with the binomial theorem, using some luck, then you can get this one. Okay? Okay. So do both sides. So first figure out what 2r choose r looks like. And then the other one is you start from the binomial theorem, and then find out how this looks like, and then how you can show that one is equal to the other. Okay, that's it. Okay, thanks. Okay, so let's end the class early today.